Okay, now let's continue the fundamental introduction. In our previous video, we learned how to deploy, okay? And the deployment represents a kind of workload. For workload, that means some resources, allocated resources for doing the computation. So in our example, we allocate 3 pods, providing the Nginx web server. Of course, we can use the pod IP, okay, to access the web server. However, pod is ephemeral or temporary because the pod can be shut down and start at any node. Each time we start a pod, the IP address is dynamically assigned. So to have a stable reference to this kind of workload, we need the concept service. As we introduce that service, would create a cluster IP, okay, representing a stable contact point. So we will have a service name and service IP. Then we contact the service IP, and the service IP will be resolved to an available pod IP, and deliver the request to the target node and target pod and target container. Right? So this part, I would like to talk about the service. Right? Just consider it's a stable contact point, right, for a group of pods. Okay? So expose an application running in your cluster behind a single outward-facing endpoint, even when the workload is split across multiple backends. That means multiple nodes. Okay, so services in Kubernetes. The service API part of Kubernetes is an abstraction to help you expose groups of pods over a network. And okay, I think we have the high-level view, so we can directly go to this one, how to define a service. A service is an object. You can create, view, modify service definition, and the service definition like this. So for example, suppose you have a set of pods that each listen on TCP port and are labeled as this one. You can define a service to publish that TCP listener. And here is the example. We create a service, and its name is my service. Okay. Then its spec. Again, the selector for the pods. Okay. So we use the labels. Okay. So when the label is matching, it will be associated with the service. The port. Right? Whenever we would like to forward the request to the target pod, right, we specify the target port. Right? So here the port is the service port. So when we access the service at the given port, right, it will be forwarded to the pod at the target port. And at pod level, we've already defined the association between the target port and the container port. Okay? So eventually, the request would reach a container. So applying this manifest, create a new service named my service. Okay? In the cluster IP, okay, this is the default one. Right? Then any pod with a given label will be associated with the service. So Kubernetes assigns this service IP, the cluster IP. I think let's go to the demonstration mode and let's see. In the service. So let's consider we've already have the deployment. So now let's define our service. So the kind is service and metadata with name my SBC spec the selector we have the app, the label app Nginx. Okay, that's our deployment. And then ports. I think we just define okay, let's try if we can use this one. Protocol TCP and port 80 target port 80. I think we can omit this one. Let's try. Okay, so micro K8s kubectl apply -f my SBC the YAML. Okay, so now let's get get services. You could see that here my SBC, it has the cluster IP, right? And listen at port 80. So let's try if we can curl okay, you could see that we access the Nginx server. Right, this is welcome to Nginx. Okay. Okay, I think services. I forgot how to, I think, get all -a. Okay, this is one way to show the related information, all the information about for Nginx deployment and here is the replica set. Okay, currently I forgot how to show the associated parts, right, to the service. Right? There is a command to do this, right? But according to our demonstration, you could see that we simply define the service and associate the service with the parts of the given label, a given label. Then the request to the service level will be forwarded to the target pod. Okay, now once we have the concept of service, and you could see that in our example, there's no external IP. Right? This is the private IP, so we cannot access the web server from the internet, and that's the purpose of ingress. For ingress, recently, just this year, there are a few news about ingress. Actually, the ingress is now considered as the legacy API. It is still maintained, okay? And however, new features will not be designed to the ingress API. Instead, the new not really replacement, but Google just say, if you would like to try some new feature, you can use the gateway API. Right? So ingress is considered as a feature complete. Right? It will not be developed from April 2026, and due to the lack of manpower to maintain, especially for the Nginx open source ingress controller. Ingress is the API. Ingress controller is the implementation, okay, and the Nginx open source implementation is basically stopped. Right? They will still maintain the security related fix. However, no enhancement, right, to the controller will be done. So for Ingress API, there's no equivalent API. If you would like to try some new feature, you need to learn the other way, the other API called Gateway API. It requires a lot of effort to migrate from the Ingress API to Gateway API. Okay, so please note that it is not deprecated. Okay? It is not deprecated. For deprecation, that means eventually it will be dropped. However, Google is announced that Ingress API is just frozen. Okay? They will still keep it available in the Kubernetes standard. Okay, so what's the purpose of ingress? Ingress is making a service public. So just consider now we have the cluster IP. We need a reverse proxy. Right? So the reverse proxy is the bridge, right, between the public network and the private network. And we can access the service from the public network. So just consider Ingress API, okay, is the API for the reverse proxy. Right? So typically, right, this is the cluster. We set up an Ingress service, Ingress controller. This is called Ingress controller. It satisfies the Ingress API. Then a client accesses the Ingress controller. The Ingress controller, based on the routing rule, and dispatch the request to the specific service. Okay. So that's the mechanism. And how to write the ingress rules? We may go to the ingress, right? Here, the ingress API. Okay, let me switch to this one. For the ingress API, right, we can deploy the kind ingress and then specify the name, the specification, right, like the class name, and then rules. Right? We may specify various kind of rules. For example, based on its protocol is HTTP and its path. Right? If the path matches test path, right, the path type is prefix. That means we have URL path start with /test path. Then we dispatch the request to the backend. The backend is a service. Right? Its name is called test. Right? The name is a service name. Right? The service name, and at the given port. So we identify a service with a service name, right, and the port. Okay, so I think ingress is actually it's actually straightforward. You may find some example rules and then apply the rules. Okay? So use kubectl to create the ingress rules, and then we can actually access it. However, in our virtual machine environment, I think we can demonstrate the path-based rules. However, there are some host-based rules like this. This is more useful, that given the different path we can dispatch to the different services, and the other way is to use different host names, right, for different services. Right? And since we don't have the domain name server, we can only use emulation to demonstrate this part. And before that, I think we need to learn here in micro K8s. You could see that here is a module called ingress. So we can use this, just enable ingress. So ingress is enabled. Let's see. Okay, so here, in addition to the core DNS, you could see that we have the special namespace called ingress, right? And it's available, right, with the ingress. So this is how to enable, right, the ingress. Okay, sorry, I forgot to switch to the demonstration screen now. Let me quickly go through that we use micro K8s and verify that here is a module ingress. So the next step is to use micro K8s enable ingress. And the ingress is enabled if you use kubectl to get all the resources and show them. You will see that here is an entry about the namespace ingress, and it's a daemon set, daemon set for ingress service. This is an ingress controller. Okay, so now according to the ingress, we have the ingress controller, and I think we need to talk about for ingress. This is the example, and you will see that its API version is networking related, and kind is ingress. So you may consider writing an ingress rule, something like this, and try to dispatch using the path-based to kind of redirect the request to different services. Okay, so I think this is a very brief introduction about the usage of Kubernetes. First, you need to enable the Kubernetes infrastructure, and then the necessary modules, and then how to deploy the workload, how to associate or how to create a service that associates the related workloads. And if you would like to make your service accessible from external world, you may consider using the ingress service. You may use path-based rule to dispatch the request, or if you can, you have your own domain name, you can use host-based rules to distinguish the services. For the demonstration, I think it's not easy to do this, because now we only have one service. If you are interested, you may deploy different, maybe your own web server and the default Nginx, and then try to write an ingress rule for dispatching to the default Nginx and dispatching to your own web server by setting up the rules, the ingress rules. Okay, so I think for this quick introduction, it's probably enough for your final project. There is a missing piece. Maybe I will give you the process on how to do the full development, develop the image, and then deploy to the Kubernetes. For this part, I think a simple document is enough. Maybe I've already have that. Okay. In micro K8s, you may enable the internal registry module. So micro K8s enable registry, similar to the case that we enable ingress. Okay? So enable registry, and you may optionally specify the size of the registry storage space. Okay? Then later, okay, you may create your image, tag the image, and then push. For the push, it's localhost, okay, 32,000. Okay, 32,000. So this is the micro K8s built-in, okay, built-in registry, and slash with your tag name, okay, use with your or image name. So we push the image, okay, to the local registry, and later in your deployment, simply access the local registry. Okay? So like this here, image, okay, access a local host. By this way, we will not go to the public registry for the image. We will contact the local registry. Okay? So this fulfills the process. Okay? Develop your image, test with Podman or Docker, and push to the local registry. Later in your deployment, okay, access a local registry for the image. Okay, I think the quick and brief introduction can be finished here.